Howdy, my name is Ethan, and I'm the founder and CEO of Mixpeek, the world's first multimodal data warehouse. And in this video, I'm going to walk you through the Mixpeek Studio, which is the platform built on top of the infrastructure that we provide. You can see all of the API documentation on mixpeek.com/docs, which contain all of the endpoints that we'll be walking through with the UI. So if we go into the Studio page, on the home page, you have all of your metrics that are then available at a high level. This is what gives you a high-level sense of how your Studio is performing. You've got your total buckets, collections, retrievers, process documents, etc. And we'll walk through what all of these mean in a bit. So if we dive into what really the end state is, it's this concept of multimodal deep research, right? So if we click one of these example queries, analyze the media trends and creative techniques present in my video collection, and combine it with the latest internet research on similar techniques, this requires a pretty sophisticated understanding of a user's object storage, right? And so if we were to run this, we can think of it as an LLM that is recursively being called and trained on a bunch of tools, where those tools are actually indexes in the customer's object storage. This is an example of what those reports can generate. As we can see, that has images, video, audio. These are all assets that are returned from this multimodal deep research. We've got a history of all of the examples, etc. Right? So we have to construct a bunch of primitives in order to support a long tail access pattern like this. Primitive number one is the concept of namespaces. Namespaces you can think of as the isolated boundary for all of your interactions in the platform. So if we go into creating a namespace, we can see we have option at the very top is to migrate from an existing namespace. This is valuable because this is what allows you to do independent testing across different types of indexes, embedding models, dimensions, fine-tuning, etc. This is really what allows you to do the versioning, the migration, the testing, rollovers, cutoffs, etc. Everything that you'd expect in a software development lifecycle, but for the index. And as you can see, we have different documents that are actually already in the namespaces that we are migrating from. So we can do that, or we can start fresh. And if we were to start fresh, we have a number of features that are available for selection. Now, it's important that we select these features up front, because features you can think of as actually indexes on your in your database, right? So if you're using Pinecone, Weaviate, Quadrant, really any vector database, you have to actually define the vector configuration up front, and they're immutable. You can't change it, right? So if we look at some of these, the visual processing feature in this case uses a face embedding that has a 512 dimension length, cosine similarity, and type float 32, as well as a payload index, right? And they all have versions associated with it. You can see these features are basically abstractions on top of the embeddings and payload indexes. And this is important because this is what allows us to then expose different feature extractors down the line when we construct our pipelines. Payload indexes are actually mutable. You can change that at any point. And these are important because if you're supporting a lot of queries that hit different metadata keys, then it's important to build indexes to ensure that those queries are performant. And we actually have a bunch of monitoring tools to ensure that any really latent queries, we can kind of profile them to see which ones are the most, that have the slowest response time, and then we can figure out why. So query profiling is a really important capability that is actually scoped at the namespace level, right? And so if we go into one of these namespaces, we can see we can't change the feature, right, as we talked about, but you can change the payload indexes, right? And that's because payload indexes are mutable and features are immutable. Features map to indexes in your vector database, right? And we can select them at any point throughout the entire interaction with the platform, right? So we'll choose staging, and you can think of these namespaces as actually also use cases across your company, right? Or lower, higher environments. All right, so then we introduce the concept of buckets. Buckets are really important because it allows you to process data that's relevant for your business in a single cohesive way, right? So if we think of an advertisement, let's say we're an advertiser and we are creating advertisements for inhalers. That advertisement typically has a number of file types. It can have a video. We'll say this is inhaler video. And let's say it also has some kind of disclosure, right? That's like the really fast speaking thing at the end of an ad. We'll call this disclosure. And then maybe it also has a PDF, and that PDF is state legislation, right? And so let's say each time we upload one of these objects, we have a unique set of these properties that are uploaded into the bucket, right? And so those buckets have to contain all of these properties together. Inhaler video, disclosure, state legislation, all have their own types of files. And optionally, if we wanted to select an S3 bucket that already is scoped in our account, we can select that, and this is what allows us to actually automatically process the S3, the objects that are S3 that are uploaded in the S3 bucket automatically. We can do filtering by tag as well as prefix. If we go into our settings page, we can see we have the ability to actually set up an IAM role that is configured to the bucket that we've selected. All right, so we've created our bucket. Now if we go into the bucket page, we can actually upload objects into that bucket. And what we see here is the objects in our bucket, the objects that we upload. Again, we have to include all of those file types. So in this case, the schema in this bucket requires that we upload a video as well as a PDF called PDF1 and video1. And we can see that here. We have to supply both of those. And if we go into our API documentation, we can see the same thing. When we create our object, that object has to contain an array of blobs where the blobs has a type as well as a property. And if it's a JSON, for example, we have data. If it's a file, we have the URL of the file, etc. And we can also include metadata prefixes, etc. And that is what allows us to kind of have a little bit of structure to the actual data storage layer. We can see some of these examples here. We have folders, and some of them are at the root level, some of them at the folder level. All right, so we have our bucket. We upload objects into that bucket, and then we have collections. And collections are where a lot of the value of the system actually is introduced, right? And so we can use two different sources as the collection processing. We can use a bucket, or we can use another collection. And we'll walk through a bucket right now. And so we can select an existing bucket. And so what this is saying is every time we upload a object into the marketing videos bucket, pass in the video, the transcript, and the metadata, which are all properties in the object, pass them into these feature extractors. And in Mixpeek, feature extractors are built, managed, and maintained by us. And there's a whole catalog of feature extractors that are available across the platform. Some of these feature extractors do quite sophisticated things like group a video by activity, group a video by face. We have different image feature extractors, face recognition, image captioning. We have text. So we have a feature extractor for every modality and every type of access pattern, right? So if we go back to the multimodal deep research, the deep research agent needs to access the data that's aligned to the indexes that you construct in order to support the results that you want. And so in order to support queries like that, we need to build these feature extractors. And so in this UI, we are passing in those properties from the bucket into the feature extractors here. So we can say in this case, the scene detection feature extractor, we're passing in the video as a property from the bucket. We're passing that into this feature extractor. It has a bunch of parameters. In this case, we're exposing the configuration to select the model. And because since it's just spitting out metadata, the model doesn't really matter, doesn't really change. But maybe you have a preference. You can change scene, change sensitivity, and a bunch of other characteristics that are unique to this feature extractor. Each of the feature extractors actually has their own set of configurations, right? In this case, model name, query text, candidate, documents, etc. And they all spit out their own types of schemas, right? So think of the feature extractors as actually the transformation layer in an ETL pipeline. But the transformation is actually powered by ML models, workflows, code, etc. So we can see, not a good example. So we go into activity grouping. We can see these are actually powered by independent models. So we have a human detection model, we have an activity recognition model, temporal grouping, etc. And they all dump out into a feature store. And you can think of that as a feature store. So we have an output. We can select a number of feature extractors, and these all run in parallel, right? So, okay, then what happens if we want to run a bunch of parallel feature extractors? What can we then do after that? Well, we can process collections as inputs to other collections, right? So we could use a source collection here. That source collection might have their own properties, and then we can pass those into the feature extractors. The feature extractors that are available are dependent on the properties that you're passing from the source. Some feature extractors have certain inputs that are not available given some file types. So for example, if we're only doing videos, then we probably shouldn't have a text feature extractor that's available for selection. We can also have automatic joins once we upload objects into our through the collection processing. We'll talk about that in a bit, as well as clustering. And then finally, caching. So caching is really important because this is a very compute-heavy process. And if we're supplying a lot of redundant file types, then we want to actually recognize that and store some of the results that have already been processed. And the caching is actually a combination of both the collection that's processed as well as the retriever, which we'll walk through in a bit. So we have the feature extractors. The feature extractors are taking in the raw objects from the bucket or the collections, and they're processing them into objects that are more useful for indexes. Right? And so we could see an example of a collection here. We have a little bit of a lineage tree for how do we actually produce the features for this collection. So we have the bucket, we have the collection, and we have a bunch of features that the collection spits into. Right? We can see an example of some of the features that have been, some of the documents that have been pulled out. Documents contain features. So in this case, the product showcase scene document contains a scene detection feature, a transcription feature, and an object detection feature. Think of these features as like indexes, and when we do a query in the long tail deep research type of access pattern, that query is spanning all of those indexes together, and it's finding the intersection of them to return the most relevant result. All right, so we have our collection. Collections have schemas. Schemas are the combinations of all of the features that have been pulled out from the feature extractors. And we can modify the metadata, the name, description, etc. of the collection at any point. So we walk through the query boundaries. Those are the namespaces. This is how we actually isolate our interactions across the warehouse. We've walked through the buckets. That's the entry point for all objects into the data warehouse. We walk through collections, where a lot of the processing happens. And then let's walk through the retrievers. And retrievers are actually a fundamental unit in the Mixpeek multimodal data warehouse, is because this is what allows us to access the data both in an ad hoc and batch way. Right? And so when we construct a retriever, we are supplying a schema as an input. And so in this case, this retriever, let's say, call this text query. And this retriever is we'll call this an image query. And so what this means is similar to the bucket construction process, is every time we execute this retriever, we need to supply an image and call it image query, as well as a text and call it text query. And again, just like the collection process, we have a number of collections that are available given the schema of the retriever. So in this case, we can search across 2 different collections given the retriever that we're constructing. And each of these collections has their own schema associated with it. So this shows us what actually will be returning when we run the retriever. And so what this is saying is every time we execute this retriever, pass in these properties and execute the retriever on these collections. And then finally, we actually have to map the stages, right? And so just like the feature extractors, the stages are actually built, managed, and maintained by our team. So let's say KNN search is the first stage in our retriever pipeline. We can say pass in image query into the KNN stage, do a search on the visual processing feature, because again, the features are mapped to the namespace. The collections have the features in it, and we can search across all of the features, across all of our collections that we've mapped in this retriever. And again, we are passing in the retriever schema, the retriever's properties into the input for this retriever stage. And just like the feature extractor, we have configurations that are parameters that are configurable when we actually define the stage. So in this case, we have a fixed constant. We say limit is 11, so we're limiting the results. Or we can do a dynamic property or a dynamic configuration. So this is if we want to actually pass in an input that is a, we could say limit, or sorry, it's an integer. We call this limit. And so now, again, whenever we execute this retriever, we can now pass in the limit as a property and then send it into the retriever KNN limit stage or limit parameter, right? And we also have pre-filters, post-filters, and just like those, we can have them be constants or dynamics. And this is important because it allows us to actually use the retriever architecture across other parts of the platform. So we can save this configuration, this stage, and then we can build another stage, right? A face search stage. And so this is actually what allows us to do a search that spans different indexes in one single retriever operation, right? In this case, the face search can only access certain features. It can only use certain input properties, etc. And just like the collection, we have caching. So for example, if we're frequently executing the same retriever using the same inputs, then we can enable caching in order to ensure that we're not overwhelming the inference service, because the inference service takes a lot longer. And if we have a lot lower latency requirements, then we can use caching. And this is valuable because we have actually dynamic cache invalidation, which really just means as we add more documents to the collection, we can dynamically invalidate the cache based off of the results of the retriever. Super useful when we're constantly pumping new objects into the collections. All right, so we walked through retrievers. Now let's walk through taxonomies. Taxonomies you could think of as joins in the traditional data warehouse world, where the joins are actually on the retrievers, or the joins are non-deterministic using the retriever architecture. And so let's take an example where we want to, every time we upload a video, we want to pull out the employees from that video, and we want to enrich the names of the employees that we already know by the document into the collections that we've processed. And so we can say, hey, take the name, department, and we can say replace or append if the name already exists in that document. And then we select the retriever, right? And so what this allows us to do, and by the way, we can also, this is the schema for the retriever. And so we can say we want to actually inherit the value that is provided from the source collection. We can use any of the schema properties from the retriever's inputs. And this is an example of what this could look like. So we are showcasing what an enriched document would look like if we attached a taxonomy to the collection. So that could be applied here. And you can think of the taxonomy application process as really one of two things. It can be computed on query time. So every time we run a query on the collection, we are doing that taxonomy join in real time. And this has trade-offs to it, right? This allows us to actually ensure that the joins, the enrichments, are using what is most up to date in the taxonomy. Or we can do save in this collection, which really just means every time we upload a new object and process it through the collection, we are doing the enrichment and we're saving the enrichment in the documents that have been processed. There's trade-offs to both. All right, so we talked through taxonomies. We have flat taxonomies and we have hierarchical taxonomies. Hierarchical taxonomies can be implicit or explicit. Implicit being we understand when you build when you create the taxonomy, we understand the relationships between the child and parents. Or an explicit requires that you actually select the collections in each of the layers and construct them yourselves. And this is valuable if you think of like an e-commerce store. You have, let's say, shoes at the top level, and then you have, let's say, high tops, and then you have, let's say, blue laces, and then you have Nike, right? That's a hierarchy of products. And if we wanted to automatically classify objects as we add them to the collection, we can use this taxonomy collection, the taxonomy enrichment process to automatically enrich the objects that we process with what is most relevant given its placement in the hierarchy. And again, because we're using retrieval, we can say what is like most relevant given that taxonomy join. All right, so we talked about taxonomies, and now let's talk about clustering. Think of clustering as kind of like a grouping operation in the traditional warehouse world, or a grouper if you're familiar with data science. We have two types of grouping. We have vector-based clustering, or we have attribute-based grouping. So if we talk about the vector-based clustering, just like the retriever operation, again, we are abstracting the vector configurations to the user always, right? And this is what allows us to actually swap in and out, or allow the customer to swap in and out different features as they become available, right? So we're selecting the feature that we want to do the clustering on. We'll say the visual processing feature, and we select the clustering method, right? So we can do HDB scan, which is the most common, k-means clustering, or agglomerative, right? And we choose a sample size. And then we have various HDB scan parameters that are specific to this clustering method. And then we can do what's really interesting is we can actually instruct an LLM to automatically label the points or the documents, or the features in each of the centroids that it determines within the clusters, right? So if we have a million videos that have been processed, we can automatically find the groups of all of the videos using this clustering system, and we can label them using an LLM. So we're saying, hey, the 3 most nearest points in the centroid, automatically send them to GPT-4o, and GPT-4o will spit out what it thinks is the most relevant label. And we can talk about scheduling and label output destinations after we walk through the actual clustering process. And something that's actually less compute intensive is attribute-based clustering. And this is more so if we are doing metadata-based clustering, right? So keys that are the same, right? Cluster by category, cluster by date, time, numerical, etc. And as you can imagine, each of these data types, because they're unique, have different clustering properties. Clustering by date time is kind of like a range operation, and clustering by category is more of a string match operation. And we also have hierarchical grouping as well, just like the taxonomy stuff that allows us to do not only flat attribute-based clustering, but hierarchical attribute-based clustering, right? And so if we go into an example cluster, we can see what that cluster could look like. So we can see that we have a bunch of different file types that have been processed into the same collection that we ran the clustering operation on. And we can see the centroids of all of the points in this collection. And we can see that each of these centroids has their own label: customer testimonials, marketing videos, product demos, etc. And we can see visually what the outliers of the documents in this clustering job is, right? And this is really valuable because it shows us what has not been captured in the clusters, and we can call these anomalies, or what could be out of distribution. We can then find similar documents, and then we can feed the results of this to a outside of Mixpeek human annotation pipeline. Super valuable if you want to have some kind of feedback loop that automatically learns things that are out of the existing classification system's distribution. And we can also see like the document that is out of the distribution. We can zoom in and do everything that we'd expect in like a very standard monitoring experience, right? So if we go back to the create clustering page, we can see we have 2 options here. Because the clustering is actually very compute intensive, we can schedule it to say, run a new clustering job after every certain amount of time, right? And set a threshold for, hey, we want to run a clustering job after every, let's say, 7 weeks. And we only want to run it when a certain document threshold has been met. And we can send the output of these clusterings into a destination that we select, right? So these are collections that are already in our account. And we can say, hey, output them to this collection and insert it if it's new, or update if it already exists and update it based off of a key that we already have, right? And so this is the clustering operation. And so this is what allows us to actually dynamically understand the relationships between our documents as they get uploaded and processed into the collection. And then finally, if you really don't want to go through this whole process of deciding which feature extractors are best, which retrievers are best, we have a quick start, right? And so this really allows us to say, hey, I want to find images that are visually similar to my reference photo. You can then upload the reference photo. We'll run an LLM to actually understand by the reference photo and the actual query what retrievers and feature extractors are most relevant given your access patterns, right? And so then we can just create the resources in your account. Done. And so then they are in your account and you can select them. One other capability that users have grown to know and love is chat with your files, right? So because we're able to construct these indexes and we have a lot of the metadata that's already been constructed, we can drag them into the chat and we can chat with them, right? We can do that with buckets. We can do that with collections. We can go into the collections and do them with documents, right? So we can do it at any level of the warehouse and we can have conversations with it. We can add different types of assets that have already been created. We can use different collections, etc. And again, we can ask questions of this the data that has already been processed, right? So that is the Mixpeek multimodal data warehouse capability. And like another kind of low-hanging fruit here is really we have the retriever operations, and as you can expect, we can run retrieval operations using the retrievers that have already been constructed in our in the namespace that we've defined up here, or that we've selected up here. So we have collections that we can select. We have different retrievers that have already been scoped to our namespace, and then given the retriever schema, we have different inputs that we can then select, and then we can run the search operation. And then we have filters that we can then pass through as well. And one other capability that we're really excited about is actually capturing the interactions of the user from these results set. So we can say, hey, maybe they downloaded it. Oops, maybe they bookmarked it, right? Maybe they downloaded it. These are signals that can actually be used to fine tune your embedding model, right? And because we have this namespace architecture, we can swap embedding models and the underlying index and help you test which ones are most performant given whatever metrics you want to optimize for, right? And we have API documentation for all of this, right? So we have the interaction suite, we have retrievers, we have model tuning, and we have everything else that you can expect from a robust multimodal data warehouse. And again, we have all of the observability stuff as well, which is really important when you want to kind of troubleshoot why some of the things are performing the way they are, right? And so again, my name is Ethan. I'm the founder and CEO of Mixpeek, Mixpeek being the world's first multimodal data warehouse, which you can think of as a traditional data warehouse, but with all the AI primitives built in from the ground up. We have all the feature extractors that you can know and love based off of whatever access patterns you can think of that all spit out different types of schemas. And we're really excited to support all of the different use cases that you can build. You can see as we expand the product, we'll have a bunch of recipes that are able to kind of one-click deploy into your account. These recipes are combinations of feature extractors, retrievers, etc. We have GitHub repos for all of them, and we can deploy them into our account with a single click. So again, my name is Ethan. I'm really excited for anybody to ask questions, to learn about the Mixpeek multimodal data warehouse, and really the space as a whole. Our focus is really advertising, entertainment, e-commerce, and education, but we're really excited for any use cases that you want to throw at it. If you're trying to learn about any of this stuff, we have a very robust set of articles on our blog, all the way from video segmentation and reverse video search into more industry-specific capabilities like how to do contextual advertising when the cookie is deprecated. And so, again, my name is Ethan. We're also hiring. Let me know if you have any questions. All of our contact information is on the contact page. We have a very active community on the forum, on our Discord, and we also have a Slack channel. If you are an active customer, we're happy to give white glove support. Thank you.